Hi, this video is for Nova Online Math 161, and we're looking at section 2.1 topic of graphing a quadratic function. Graph label at least 3 points. We have f of x equals -1/2 times x minus 2 squared plus 4. Notice this is in quadratic transformation form. So that x minus 2 inside the parenthesis will shift the graph right 2 units. And if you look outside, that we have that plus 4 right there, that will shift the graph up 4 units. So where is the vertex at? Used to be at origin, but now this graph has been shifted right 2 units, so the x-coordinate is +2. This graph has been shifted up 4 units, so the y-coordinate of the vertex is 4. So let's plot 2, 4, and we're going to need 2 more points after that, right? So I will plot. Draw xy axis, go 2 to the right, go up 4, and plot that vertex right there. I am going to use the axis of symmetry to graph this parabola. So let me draw a vertical dotted line, vertical dotted line, going through x equals 2. And what do we call this line? We call this line the axis of symmetry. Remember, axis of symmetry always goes through the vertex, and the equation will be x equals the x-coordinate of the vertex. So the axis of symmetry is at x equals 2. We got a vertical dotted line sketched at x equals 2. Now, I just need to plot one point to the right of it and 1 point to the left of this, okay? What's a good number we can plug in? Now, looking at that, we have to take the -1/2 of this number. I do want the number to come out to be an even number, because I can take half of even number and I don't need to worry about getting a decimal value, right? Or fraction. So let me think. I'm just going to randomly pick x equals 4. What will happen if I plug in 4 into this function? So I'm trying to plot a point at 1, 2, 3, 4 to the right. So let me plug in 4 into the function. F of 4 equals -1/2 times 4 minus 2 squared plus 4. So let's evaluate this. We'll get -1/2 times 2 squared plus 4. That's -1/2 times 4 plus 4. And -1/2 of 4 is -2. So the y value comes out to be +2. So we are going to plot another point at 4, 2. So go 4 to the right, go up 2, and plot a point. Now, what I'm going to do is I'm going to use the axis of symmetry idea to plot the other point instead of plugging in, okay? So I have a point that is 2 to the right of the pink axis of symmetry line, right? So to make this graph symmetric about this pink line, I need to go 2 to the left of this graph, of this axis of symmetry, and I should have a point at 0, 2. And we can get the same number by actually plugging in 0 into the function. But, you know, once you have the axis of symmetry graphed, we can use that symmetry idea to plot the other point. So here we have it. Here's the parabola with 3 points, with the vertex at 2, 4. And 2 additional points that we got plotted are 4, 2, and 0, 2.